All right. Today's material, I'm putting a video up here uh, so that it'll help those of you who can't get to class or whatever the issue is, and you also have a review opportunity. So we'll try and go back to what I've done before, where I post a video, but I'll also teach this lesson during class time. And I can cut it down during class time versus trying to explain everything during a video like this. So. Yesterday, what we did is we added and subtracted polynomials. Today, we're just practicing multiplying. And then tomorrow, we'll get into a little bit more complicated stuff. It takes quite a bit of effort for you guys to comprehend. But let's go ahead and take a look at a few examples here. All right, and all we're doing is just taking a polynomial. So remember, polynomials have positive exponents, and they're nice whole number exponents. So we're taking a 12x cubed, and we have to multiply it by this other polynomial, 2x squared plus 4x plus 1. It's just distributing. Okay, so we're just going to distribute this guy. Okay, now just remember when you're multiplying like this, what you end up with is, so we got to do the 12 here times the 2, and that's 24. And when you multiply x cubed times an x squared, you just add those exponents. That's a total of x to the 5. So there's 5 of these x's multiplied together. That's like 24 times x times x times x times x times x. Then we do our next distribution, the second one here. So we have to do the 12 times the 4. Well, that's a 48. And then we add the exponents on the x's. Now that's an x to the first right there. If we don't show it on the x or the variable, it's just a 1. So 3 plus 1 is 4. So that's x to the fourth. And then lastly, we distribute that 12x all the way to the 1. So it's 12 times 1 and times the x cubed. And so we just stop right there because these are not like terms. We got an x to the fifth term, a fourth term, and a third term. We can't add those together. We just stop there. We are finished. So let's get a little more complicated. Here we have what's called and I want to write these words down for you because some of you I've noticed in your homework are naming these things wrong. This first polynomial here, this would be called a quadratic. And the reason it's called quadratic is because it's got an x squared as its highest exponent. And it would also be called a trinomial because it has 3 terms in it. So this is what we call a quadratic trinomial. The second one here would be called a linear because it's x to the first power. And it's got 2 terms, an x and a plus 4. So we'd call this a binomial. Bi meaning 2. And we've talked about that before as well, but I just want to reiterate that so we start to understand how we name these guys. Okay, so I got a quadratic trinomial times a linear binomial. I do exactly what I did in this previous problem where I have to distribute. But now I'm not distributing just a single term. I have to distribute everybody in that quadratic trinomial. Each one of these has to be distributed. Okay, so it's just a big multiplication process. So I'm going to erase a little bit here and then we'll walk through that process. So here we go. First thing I'm going to do is distribute this 2x squared. So he gets spread out to these other 2 terms. So I have to do 2x squared times x. Well, that's 2. And then I had an x squared times an x. So that's x cubed. Then I do 2x squared times 4. So that's 2 times 4, 8. And I've got the x squared. So I've distributed him. Next, I'm going to distribute 3x. So I have 3x times x. Well, that's a 3, and x times x is x squared. And 3x times 4 is 12x. And then lastly, I distribute the 1. 1 times x is just 1x, and 1 times 4. So I've done all my multiplications. Now it's just a case of looking for like terms. So here I've got an x cubed term, but nobody else has a cube on it, so that's the only x cube I have. Then I've got an x squared term, but here's another x squared term, so those two can be added together. And 8 plus 3, so that's 11x squared. I've got myself a x term, 12x, plus another x, that's a 1x, so that's a total of 13 x's. And then lastly, I've got this 4, and he can't match anybody because he's the only term left. And so I've just carried out that multiplication, and that is in standard form. Exponents go 3, 2, 1, none. Okay, and I've combined all my like terms. And then the last example for this multiplication, actually I've got one more after this. Here I've got a trinomial times a trinomial. Looks very, very complicated, and it is not. It's just a lot of work. So what we have to do is, again, let me name these for you so you understand. This would be a quadratic because it's x squared is the highest degree. And it's got 3 terms, so I call it trinomial. So quadratic, x squared, trinomial, 3 terms. And the other one is also a quadratic trinomial. 3 terms, highest exponent is x squared. So it's a quadratic trinomial times a quadratic trinomial. And all we do is this distribution process. So here we go. 2x squared has to be multiplied by each of the terms in the other trinomial. So 2 times 3, this first one right here, 2 times 3 is 6, but I've got an x squared times an x squared, so that's going to be a 6. And then I have to add those exponents, x to the 4th. Here comes my next distribution. 2 times 5 is 10, and x squared times x is x cubed, so that's a 10x cubed. And then lastly, I have 2x squared times 7, so 2 times 7 is 14 times that x squared, so 14x squared. And I'm going to distribute again here with the negative 4x, but I'm going to, as I write these down, I'm going to do something just a little bit different, so I think it makes the math easier. But I have to distribute that negative 4x to everybody. So negative 4 times 3, that's my negative 12, and x times x squared, that's an x cubed. So it's going to be a negative 12, 3 times 4, x cubed. So I'm going to write it this way, negative 12x cubed. I'm going to line it up underneath the x cubed from my first distribution. I'm going to go negative 4x times 5, that's negative 20, and x times x is x squared, so negative 20x squared. And then I'll do the next distribution, negative 4 times 7, negative 28, and an x, so negative 28x. So I've distributed the first 2 terms of that quadratic trinomial. Let's distribute this third term. It's a, I believe that was a positive one to begin with. I hope so. If not, then I'm going to goof this up, but let's assume it's a positive one right there. And I'm going to distribute him. So I'm going to go 1 times 3x squared. and that's a 3x squared, so I'm going to write him underneath the x squared terms. And then I'll go 1 times 5x. Well, that's a 5x. I'll line him up under the x term. And then lastly, I'll do 1 times 7. So I've distributed it, but also at the same time, I've aligned everything so that I can just add vertically to figure out my final answer. And so we just start at the left-hand side here, and well, that's just 6x to the 4th. Then we go to the x cubes. I've got 10, take away 12, so that's minus 2. And it's x cubes that we're counting up. Next, I got 3 terms to add. I got 14, take away 20, so that's negative 6. And then negative 6 plus 3 is negative 3, so it's negative 3 x squareds. Then I do my x terms here, negative 28 plus 5, that's negative 23. And that's the number of x's I have. And then lastly, I just have this plus 7 hanging out there. And so if you kind of, as you multiply, line them up in this fashion, it makes it so much simpler. There's a lot less writing that you have to do. If you don't do it this way, it takes a lot more space because now you have to go horizontally. And so if you wrote it this way, so there's my first distribution, the stuff in black up there. My second distribution, look how long this is going to get. 28x. You could certainly just write down all your answers as you distribute this way, but now we got to go hunting and pecking kind of sort of thing and go, okay, do I have any other x to the 4th? No, I don't. Do I have any other x cubes? And I have to go looking for those. Do I have any x squareds? Yeah, I do. That's 14 minus 20 plus 3. That's negative 3. Then I have to go to my x's. Negative 28 plus 5. That's negative 23 x's. And then finally my plus 7 on the end. So to me, if I'm multiplying like this big trinomial times a trinomial, it just is easier to set it up like a big addition problem. You don't have to. You get your choice. You can either do it this way and set it up after you distribute, or while you're distributing, or write it like this while you're distributing, and then look for like terms. Just depends if you can kind of think of two things at once, it'd be this stuff. If you just want to do all your multiplications and then look at how to line things up, you would do that second method. Now the last example I have is what happens if we had a binomial. It's called a binomial. It's got 2 terms in it. Sorry, I'm getting a lot of messages here. And the colors here don't matter. I'm just trying to group them that way. Times another binomial. So we can multiply lots of binomials, trinomials, whatever. We can multiply them all together. And the way you want to think about a problem like this is just like you would think about this problem. 6 times 5 times 8. If you were having to multiply 3 numbers together, you'd take the 6 times 5, get 30. Then you'd multiply it times the 8, which would give you 240. This is the same concept. We're going to multiply the first two, get the answer, And then once we have that, we're going to take that answer times the third term there, or the third factor, x plus 6. So let's go ahead and do that. So I'd multiply these first two together first. So I just take the 2x and I distribute. 2x times 3x, that's 6x squared. And then 2x times negative 2 is negative 4x. Then I distribute the 5. 5 times 3x, 15x. 5 times negative 2, negative 10. So there's the first two multiplied together. I haven't even touched the x plus 6 yet. Now, you could distribute this has got 4 terms in it, but note these two in the middle. These are like terms there. We can add those. And you want to add those because it makes it a smaller polynomial. Negative 4 plus 15 is 11. And so now we don't have to do as much distributing. Had you left it like this, you'd have to distribute 4 times. Not 4 times, actually 8 times. You'd have to multiply twice for each term. So it's much easier to simplify it and then do the distributing. I also want to show you this. Well, you can certainly multiply in this order. I've always liked putting the smaller polynomial first. It always felt like less work to me. It's not. But we can multiply in any order. So 2 times 3 is 3 times 2. You can do the same thing with polynomials. You can multiply left to right or right to left, or you can just flip-flop them. So now it seems like less work. I'm distributing x here. Is all. So x times 6x squared, that's 6x cubed. X times 11x is 11x squared. X times negative 10 is negative 10x. Now I'm going to distribute the 6. That's 36x squared, so I'm going to line him right up with my x squareds. 6 times 11, that's 66 x's. And then 6 times negative 10, that's negative 60. I'm going to strike a line and just add those two together. 6x cubed, that looks like it's going to be 47x squareds, 56 x's, and then minus 60. And I've just multiplied 3 binomials, bi meaning 2, so each one had 2 terms, and these are all what we call linear binomials, because they're all x to the first power. And binomial, because they all have 2 terms in them. So it's a linear binomial times a linear binomial times a linear binomial. And that's what we'll be going over in class. So I hope you show up so you can ask questions about this. And I'll show different examples in class. That way you have a variety of examples to look at.